Okay, so to understand the concept of rotational motion, each parameter of rotational motion, which kind of parameter? Like angular displacement, like angular velocity, like angular acceleration, like torque. We have to compare all these parameters with the linear motion, with the translatory motion. Okay, so as in the translatory motion, as in translatory motion, we understand the concept of linear displacement, linear displacement, it is delta r vector, okay, and measured in meter, measured in meter. Same concept we can understand, same concept we can understand for angular acceleration, sorry, angular displacement. In rotational motion it is angular displacement. Okay, so what? So as in translatory motion or linear motion, we understand the concept of linear displacement delta r, which is measured in meter. Same as it is, we can understand the concept of angular displacement in rotational motion. It is denoted by delta theta and measured in radian. Okay, you know very well what is meaning of angular displacement. Already we have covered in circular motion. What is meaning of angular displacement? It is a vector quantity. It is a vector quantity, and what will be the direction of this angular displacement we have understood. Okay, now the linear displacement. After the linear displacement, the second parameter is the linear velocity. Linear velocity. You know very well what is the linear velocity. It is v vector and it is delta r vector divided by delta t. It is measured in meter per second. We know very well. So as we understand the concept of linear velocity is translatory motion or in linear motion, same as it is in this rotational motion, we can understand the concept of angular velocity. Angular velocity. Okay, and this angular velocity denoted by omega vector. Omega vector, it is delta theta vector divided by delta t. Rate of or displacement, angular displacement per unit time. Okay, angular displacement per unit time. It is measured in radian per meter square. It is measured in radian per second. Now the third parameter is acceleration. Third parameter is linear acceleration. Linear acceleration. So the linear acceleration a vector is equal to, you know very well, dv by dt, rate of change of velocity, and it is measured in meter per second square. Okay, same as it is in rotational motion, we can understand angular acceleration. Angular acceleration. Okay, it is alpha vector denoted by alpha. And what is alpha? It is d omega vector divided by dt. Okay, so it is angular acceleration. It is measured in radian per second square. Radian per second square. Okay, so we can understand the concept of angular acceleration in rotational motion, same as it is the concept of linear acceleration in translatory motion. Now the fourth category. The fourth category is the mass. As we are using mass in translatory motion, okay, we have to use moment of inertia. Moment of inertia denoted by I, and it is equal to mr square. It is equal to mr square. What is r? R is the distance from the perpendicular distance from the axis of rotation. Okay, so as we are using mass, it is inertia of motion, same as it is the moment of inertia of rotational motion. Moment of inertia of rotational motion. In case of rotational motion, we have to use the moment of inertia at the place of mass. It is very important concept, and this next video, next lecture, we will cover all the concept of moment of inertia, what is the formula for the moment of inertia, how you can find the formula for the moment of inertia mr square, and how we can find the moment of inertia of different type of body having different shape, like circular disc, like circular ring, like cylindrical, solid cylinder, hollow cylinder, spherical ball, spherical shell, solid sphere, all these type of shapes. Okay, all this type of body we will find the moment of inertia for this kind of bodies. Okay, so it is very interesting concept. This concept of moment of inertia is very interesting. Now, as we are using mass, we are using moment of inertia. Now, if we talk about the force, okay, fifth concept is force. It is F vector, and this F vector is equal to mass into acceleration in our translatory motion. You know very well, if mass of any system is constant, this force is equal to mass into acceleration. Same concept we will use in rotational motion, which is the torque vector. Okay, in translatory motion, as we are using force, in rotational motion we have to use torque. So, the torque vector is equal to I into alpha vector. Okay, and what is the relation between torque and force? This torque vector is equal to R vector cross F vector. Okay, in video of torque, in lecture of torque, we will understand what is meaning of torque, but right now if we are comparing translatory motion and rotational motion, we have to compare the force with the torque. As we are using force, which is equal to mass into acceleration, same as it is, we can use torque in rotational motion, which is I into alpha vector. Okay, which is I into alpha vector. Now, the next parameter, sixth parameter, is kinetic energy. So, the translatory kinetic energy is equal to half mv square. You know very well what is the kinetic energy, half mv square. Same as it is in rotational motion. Rotational kinetic energy. So, what is the rotational kinetic energy? It is half I omega square. Okay, very simply you can understand, as we are using mass, we have to use moment of inertia. As we are using linear velocity, we have to use angular velocity. Okay, so we can compare, we can understand, we can memorize the formula for the kinetic energy very easily for the rotational motion, as we have known about the translatory kinetic energy, which is half mv square, same as it is half I omega square. Now, if we talk about the work done, so the translatory work done, okay, translatory work done, W is equal to F dot delta R. It is the formula for the translatory work done. Same as it is the rotational work done. Rotational work done, torque vector into angular displacement. Okay, the dot product of torque into delta theta, angular displacement vector. So, with the help of this parameter of translatory motion and parameter of rotational motion, we can understand all the concept of rotational motion. Okay, how we can use different formula, different derivation for the rotational motion. Okay, but the one concept, only the moment of inertia. The moment of inertia is totally different. Okay, as we are using mass, we have to use the moment of inertia and translate.